Welcome back. In this video, we're going to begin to talk about how computers store data. We've come a long way in this video series. We've gotten a good understanding of kind of the guts of a computer, and we've talked about how they work together and how the internet works. So now we want to begin to move towards becoming programmers. And in order to do that, we really need to understand the very lowest levels of representation, at least for this course at an introductory level. So you've done a lot of really good work so far, and what we need to do now is begin to understand some of the theoretical constructs on which computer science is built. Okay, so we're going to begin with talking about a term that I really like. It's called abstractions. Okay? And when we start with computers, we start with ones and zeros and binary. And we're going to talk about that extensively in the next few videos. But basically, binary thinking and binary logic is the fundamentals to a computer. And after that, we begin to represent information in higher and higher levels. So we have ASCII and Unicode. We then move into machine code. And then we have assembly language, and then we have some of the higher level languages, well, really all of the higher level languages, which are more in tune with the way we speak. They're easier for us to get our heads around, and they're more powerful with less code because we've already abstracted our way into a higher level of abstraction. So when we talk about binary thinking and binary math, that's really the first abstraction of how do we take a switch position that's on or off and have it mean things, okay? So let's talk about binary state. Well, binary means one of two choices, okay? So mathematically, we're going to be working in base 2. But binary can be broken down to the switch is on or the switch is off. And I want to really kind of let that sink in because it really flavors everything we're going to talk about. So a light bulb is either on or off. It's pretty simple, right? It's on or it's off. And we have switches that we use every day that sometimes we don't even think about the fact that it's representation of a status of the power's on or the power's off. Okay? And here's one that I've actually had a couple other teachers and adults say, boy, I didn't even realize that when I look at that button. You'll find these on stoves and ovens and things. It's kind of an artistic 1 and 0 for a power button. It's either on or it's off. So binary state is part of our lives every day. We don't even notice that we use it anymore, which is kind of cool. It should make this a very simple concept for you to get your head around. Now, here's a little nerd humor for you, right? You'll see this on t-shirts, right? There are 10 types of people in the world, those who understand binary and those who don't. Wait, what? Hopefully by the end of this video, you'll understand what this actually represents, okay? All right, again, and I'm really not trying to beat this. I just really want you to understand it. We're going to start at the very ground. And the smallest piece of information that a computer can store as part of what's known as its state is a binary digit, which is a bit. And the word bit comes from binary digit. Okay? There's a little piece of trivia for you. You'd be surprised how many people don't know that bit comes from the term for binary digit. Okay, so we have a bit. Now, that's not very useful. I mean, it's like a power switch, but we want to line up these bits so that they can mean more and more things. So we can organize them, and the basic unit of organizations are here. 8 bits makes a byte, spelled B-Y-T-E. However, because, well, nerds, half of a byte is a nibble. You just can't make this stuff up, right? 2 bytes, however, if we double this, is known as a word. All right? And those are just terms you need to be familiar with. So if we look at a word, which is 2 bytes, half of that is a byte, half of a byte is a nibble, and any one of these ones or zeros is a bit. So in each position along here, you have different bit positions that represent powers of 2. So let's talk about numbers. Numbers, if we organize a byte of bits, 8 bits in a byte, we use each bit position, like I said, to represent a power of 2. And we start with the 0 power, because any number to the, and I apologize, I'm going to sound like a math teacher here for a minute, but any number to the power of 0 is 1. And obviously we need to account for the number 1. So 2 to the 0 is 1, and 2 to the 1, right? Any number to the 1 power is itself. 2 squared is 4, and then we just keep doubling because we're in binary, all the way up to 2 to the 7th, which is 128. So if you're doing byte math, especially for this class and some of the exercises we do, you may just want to go 1, 2, 4, 8, 16, 32, 64, 128. And when I do this in my class, half the time I'll do, right about here is where I get it wrong because I've been doing it 300 times a day. So make sure that you go 1, 2, 4, 8, 16, 32, 64, 128, and you make sure you've got 8 of them written out so that you don't, do something silly or stupid like me. Okay, so let's take a look at a number in byte or digital format. We have turned on the 2 squared and the 2 to the 0, or 4 and 1, so this binary number should represent 5, which of course it does. Okay, now this is where I want to pause and tell you why this stuff matters. Okay? And I'm not going to belabor this point, but I want you to understand that it's really important to know this. Computers are a physical model of what we do in the real world. And a computer only has so many bytes available to it. Even if it's got an awful lot available, as programmers, we have to sometimes, even in our software, tell it how many it can use for a given computation. And we do that by declaring certain data types, which you will learn as you get into programming. But having enough available bit positions for the math you're doing is really, really critical. And I'm going to give you a real-world example that comes from the first Gulf War, which I was in. And it happened on February 25th, 1991, in Dhahran, Saudi Arabia. This is a Patriot missile battery. And Saddam Hussein was firing Scud missiles at the time at our troops, at our bases. And these missiles were originally designed to take out subsonic enemy aircraft. The problem was the Scud missiles, as we discovered, were at tip over beginning to hit supersonic speeds. And the registers in memory for the systems only had 24 bits available for the math. Well, the calculations caused what was called byte flashing, because it would throw a bit to the next register that didn't exist because it only had 24 bits. So it would carry off, and what was left on the register became zeros. And these missiles were missing in close. They were not hitting the Scuds as they were coming in. Now they quickly figured it out. The problem is we missed, on February 25th, 28 soldiers died and 100 people were wounded. Now, that's 28 funerals because we didn't have enough bits available for the math that was occurring in these radars. Now, I'm not passing blame. I'm using this as an example of why it is critically important that you allocate enough memory and registers to what you're doing. Now, when I tell this story in class, a lot of times kids are like, that's 30 years ago. We're smarter now. Well, let me tell you something. Many of you will become engineers and programmers as we build vehicles that are headed for Mars, or the moon, or bases on the moon, or self-driving cars, or self-flying vehicles that take us to work and back. What you do in computer science can actually affect the lives, physically, of people who are relying on the software that you develop. Medical systems. We're talking about growth in robotic surgery, where the surgeon can be 100 miles away performing surgery on a patient in the far reaches of the world. Okay? These types of technology, you've got to have enough physical bytes allocated to do the math you're doing. Okay? So I want you to understand that I didn't just pull this out of the air. I really think that it is critically important as a programmer that you understand the fundamentals of what you're doing. Okay? And here's the sad part. The software fix got to Dairon the very next day. Okay? All right. In the next video, we're going to go into ANSI. But for this one, I really wanted to stop and talk about why this matters. Okay? And to give you an idea that everything we do is standing on the shoulders of those who came before us. I'll see you on the other side.